So in this problem, they tell us c of x is equal to x cubed. This is my parent function. And d of x is c of x plus 1 plus 3. So this is my child function. Some people call that the mother function or daddy function, and the kid function. Write d of x in terms of c of x. So I recognize in this problem that d of x, I need to write d of x, but it also has c in it. Well, this c function is just x cubed. Space. So I'm just going to rewrite this. D of x equals, my c function now is x cubed. Do you see that? I didn't write the x though, I put a parenthesis. Because in d of x, it tells me for every x value, we're going to put in what? X plus 1. So I'm trying to show you a visual. So essentially, we're taking all of this and putting it here. Again, what's different about this one is that your input, x plus 1, goes there in the parentheses. So class, what am I going to write there in blue? X plus 1. And then don't forget to bring down the plus 3. To finish this problem, x plus 1 to the third power, is it going to be x to the third plus 1? No, you got to expand that out. We've been working on that, right? So I'm going to multiply those with the box first, and then I'll just add 3. Here's my box. So I'm going to do the first two, x plus 1, x plus 1. Class, what goes there? Here, here, and here. So we just multiplied there. Now let's go ahead and add. Class, what goes here? So we're just combining like terms, x squared, 2x, and 1. And I'm going to go here and I'm going to use the next x plus 1. Class, let's go ahead and multiply. X cubed, 2x squared, x squared, 2x, and 1. So if I go ahead and combine like terms, all of this, what can I write over here? X cubed, good, 3x squared, plus 3x, plus 1. And I still have that plus 3 here. So my final answer is going to be x cubed plus 3x squared plus 3x plus 4. Raise your hand if you got that. Good. So in this problem, this is called, we've expanded it. And if you think about it, polynomials can be written in standard form. If you think back to quadratics, this is just like standard form. Notice how it's in descending order, and there's no what? There's no parentheses. Okay? So we completed part A, write d of x in terms of c of x. The second thing I want to talk about is the rule. Well, that goes back to our A, B, C, and D. In this problem, there is no a value. A value is not equal to c. Class, do I have a b value? Do I have something in front of the x? No. And do I have a c value? What is my c value, class?
1.
Is it a positive or negative one? Negative 1. So here, the reason why it's equal to a negative 1, so your negative 1 affects your x values, because this is adding x, go left. That's the minus 1. Sorry. And this plus 3 is your what? That's your d value. So your d value is 3. This tells you it goes which direction, class? Up 3. So if it's going up, which axis is that? The y. So I'm going to write a plus 3 here. Because the d value makes it go up and down, that's the y values. This one goes left to right, that's the x-axis. Does that make sense? Okay, so we just created a rule, and this is our rule. Parentheses x minus 1 comma y plus 3. Let's do this last part called the table. X c of x, x d of x. We've done the parent function before. And in our parent function we did 0, 0. Where are my other coordinates, class? 1, 1, right? 1 cubed is 1. How about 2? 2 cubed is 8. Okay. So there's two ways you can do this second table. You can either apply our rule to the parent function, or you can just take these values and put it into this really big function, which will take you a long time. So let's go ahead and use our rule. I'm going to take x and subtract 1. So if I take this 0, put it here, 0 minus 1 is negative 1. If I take the 1 here, 1 minus 1 is 0. And 2 minus 1 is 1. So this reflects the shift going left 1 unit. Add to x, go west, right? Now the d of x is taking this column, and then we're just going to add 3 to it. Class, what's 0 plus 3? 1 plus 3. And 1 plus 3. I'm sorry, 8 plus 3. 11. So if you just did a quick graph, just want to show you what's happening here. Parent function in this blue color looks something like this, right? But d of x, we know that it is being shifted up 3 units and to the left 1 unit. So it's probably going to look something like this. Right, and being shifted down 3 units and to the left 1 unit. Probably not so dramatic that way, but just give you an idea of how you can actually now, it affects your table. So in this problem, to review, I've taken the parent function, I've done some polynomial transformations to it. I can do write it in my substitutions to get a standard form. I can use the a, b, c's, and d's to write a rule to my coordinates x and y. And the third thing I can do is I can create a table that helps me transform the graph.